Well, today we will be studying about how to do test analysis in our studio. First of all, you need to import the datashet from Excel file. I need to browse it. It is in downloads, spray, open. The data is being retrieved. Now click import. I'm opening a new file, RScript, to analyze it, RScript. Now I will add the command here, attach, spray, control, enter. Now the file is attached. First and foremost, we should know why we are doing a t-test analysis. T-test is one of the tools of inferential statistics that is frequently used in data analysis. It is used to determine the significant difference between the means of two groups. And it is used as hypothesis testing tool, which allows researcher for testing an assumption that is applicable to the population. It looks at the t statistics, t distribution values, and degree of freedom to determine the statistical significance. If we are testing means for three or more groups, we should go for analysis of variance, because the test only analyzes the mean for at least two groups. And there are certain assumptions that we should know before doing t-test. First, we should be using t-test for analyzing bivariate type of data. And the continuous variable must be, the independent variable must be continuous in nature. And each observation of dependent variable is independent of other observation. And dependent variable should have normal distribution. It should have equal variance. Then only we can do independent sample t-test. And there are various kinds of t-test we can do. First one is one sample t-test. It is used to compare mean of a single group against some known mean or gold standard value or widely accepted value. Similarly, paired sample t-test is the second type, and it is used to compare means from the same group at different times. In other words, we can say that it is used to compare means of longitudinal data. And the third one is independent sample t-test. It is used to compare means of two groups. Now let's move on to our data, and let's move on to the test that we will be doing. First, let's see whether our data is normally distributed or not. Whether our data is normally distributed or not, let's see it. So for it, I'm writing a code QQ norm. Let's see the variable. Let's see first the data add SPRAY, and I want to see the four observation. So I'm writing head as. Now let's see the number of insects, uh, whether they are normal distributed or not. QQ norm variable. I'm seeing chemical spray, mustard I1, and I'm given semicolon QQ line QQ line mustard I1. We can see, as long as the data are along the straight line, we can see that they are normal distributed. There are some observations which are not, which are away from it, meaning they might be the outliers. This variable and this variable might be outliers. Let's get confirmed by another option. We need to load the package called as R. Now QQ plot R, QQ plot R file name. Our file name is spray spray, and give $sign and mustard I1. According to this plot, the case number 14 and 18 might be outliers, but let's check the normality. Now I'm checking the normality. I'm checking the Shapiro test for normality. Shapiro that test, and our variable is mustard I1. Yes, we can see the p-value is less than 0.05. It means that the null hypothesis, the data are not normally distributed. If the value was greater than 0.05, then we can assume that the data are normally distributed. In this case, we have rejected the null hypothesis that the data are normally distributed. It has violated the assumption that is needed for normality. In this case, we cannot do the parametric test. We should go for suitable non-parametric test. But for now, I'm moving on with this test to see, to observe our values. Now, first, I am doing one sample t test, and it is done when your dependent variable is continuous, independent is some national average value of the same. In this case, we will do t dot test. We'll be doing t dot test, and variable, our variable is, we should do it, and mu is the gold standard value, and what is it? So based on this, we can do our test. T dot test, our variable is, let's check for yield. yield of mustard and sorry yield of mustard and mu is equal. Suppose if the average yield of mustard in our case is 900, so I'm writing mu is equals to 900. What does it show is that the p-value is less than 0.05. It is less than 0.05, assuming that we should now reject the null hypothesis that the true mean, the average yield is equal to 900 kg per hectare. Now, as the t-value is positive, we can see that the average yield of mustard in the studied area is significantly different than, or significantly higher. The average yield is significantly higher than national average, and we'll write these things, and t value is equals to 2.32, degree of freedom equals to 19, and p is less than 0.05. It is how we present our data. This is for one sample t-test, and now we will be doing paired sample t-test. It is, as I have said earlier, it is done for longitudinal data. So the code for paired sample t-test is t.test variable 1, variable 1, variable 2, paired is equals to true, paired is equals to true, comma, and alternative. We can write it for other also. Alternative is equals to two-sided. Alternative is equals to two-dot-sided. Now let's put on our variable t.test. Our variable 1 suitable for paired t-test is mustard I1. Mustard I1, and second variable is mustard I2, paired equals to true, and alternative is equals to two-dot-sided. As the data are constant, so we cannot perform this test. At least let me do these things, and if see data are constant, there are no such increase in temperature and in the values, so we are not being able to perform paired sample t-test, but this is the way how to perform our analysis. Now let's do the independent sample t-test. Independent sample t-test. For it, the code is t.test variable 1, variable is governed by factor data is equals to file name and then var dot equal 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 is equals to true. Var equal is equals to true. So I'm writing the command, I'm giving a name for it. Result is equals to e dot test variable. Our variable we are seeing mustard I1, mustard mustard I1. It is governed by chemical spray, chemical spray. Data is equals to spray spray var dot equal is equals to true, and then res enter. Here we can see the number of insects seen is significantly different in the plots where chemical pesticide is sprayed and in the plots where chemical pesticides is not sprayed. In other words, we can say we can reject the null hypothesis, and we can explain that the number of insects is significantly lower in plots where chemical pesticide is spread as compared to control, and we have to write t is equals to 10.097, degree of freedom is equals to 18, and p is less than 0.001. So we can write that the number of insect is significantly lower in plots where chemical pesticide is sprayed as compared to the control, and t value is 10.097, degree of freedom is 18, and p is less than 0.001. So this is the way how we perform independent sample t-test. Now let's check the normality assumption again, and the assumption is that I'm writing the code for it. With I'm checking assumption for independent sample t-test with bracket, file name is spray sapiro.test, variable is mustard I1, mustard I1, and then factor is chemical spray, chemi chemical spray, chemical spray is YESS. Control enter. So as the p-value is greater than 0.05, we can say that the data are normally distributed. Say again, let's do for Shapiro.test mustard I1 bracket chemical spray equals to no. As the sample is not more, that's why there is a problem. It's the way how we perform the Shapiro test. As mentioned above, we can say that as the p-value for normality test is greater than 0.05, we can assume the data are normally distributed. We can assume that the data are normally distributed as p-value is greater than 0.05 in Shapiro-Wilk test. Now let's check for homogeneity of variance. There are various tests for doing homogeneity of variance. We can do Bartlett test, we can do Levin test, or we can do a Klinger test. First, let's do it. res.f test var.test bracket variable means chemical spray, factor means chemical spray. Sorry, the factor. Mustard I1 chemical spray. Mustard I1 chemical dot spray. res dot f test. We can see that the p-value is greater than 0.05. We can assume there is equal variance. So I'm writing it as the p-value of variance test is greater than 0.05. We can assume the equality of variance. There are various tests for performing equality of variance also. Example, we can or Bartlett dot test variable is mustard I1 and factor is chemical spray. Bartlett test is also the test for homogeneity of variance. We can perform this test as well. There are other tests also. Suppose there is another Flinger test, or Flinger Flinger dot test mustard ion chemical spray, or LEVE LEVENE Levin Levin test mustard ion chemical spray. Yeah, in this case also, p value is greater than 0.05, and in Bartlett test also p value is greater than 0.05, assuming that our the variance of the observation are equal between the two groups. In this way, we can perform normality test, we can perform homogeneity test, and we can perform various t test. It's this much for now. Thank you very